Hello students, this is Kainat from Alamgul and today we'll learn some of the numerical. We'll got to know about how to solve how to solve the numericals on mirror formula. Okay, so here we go. There are three questions that I have come up with. So we'll solve one by one. First question is asking Rohit wants to have an erect image of an object using a converging mirror of focal length 40 centimeter. Okay. F is given as minus 40 centimeters. Since this is converging mirror means the concave mirror. It's talking about concave mirror. Okay. It's talking about concave mirror. So F is given, the focal length is given as minus 40 centimeter. Specify the range of distance and what it's asking, what it wants. Rohit wants to have an erect image of an object. So just recall the ray diagram. In ray diagram, when it was about the concave mirror, when we were getting the erect image of an object, when we were getting that, we were getting when the object was it was only one it was only one position of the object from which of which we were getting the erect image of an object, right? So what was that position? The position was between f and between f and focus and pole, right? Between focus and pole. And what it's now asking, fine, means the object should be placed between focus and pole. Now what it's asking, specify the range of distance where the object can be placed in front of the mirror. So it's asking the same question that we have to specify the range of distance, not the fixed distance, but the range of distance. Means like if this is the concave mirror, this is the concave mirror, and this is the focus, this is the this is the center of curvature. Okay, means the object should be placed between focus and pole. Okay, so that we'll get a image in behind the mirror, and it should be erect, right? Erect means virtual, so it means erect image will always be virtual. So how will be the ray diagram of this? This is the parallel ray, so it will pass through the focus. It will pass through focus. Okay. Fine. We'll just okay. So this will pass through like this, but we have extended this line uh, towards the to behind the mirror. Okay. Now it will be with the dotted lines. Now what is the next one? Next one is the next ray will be the ray that passes through the center of curvature get reflected gets reflected along the same path, right? And then it will appear to meet somewhere after the behind the mirror, and it will where it's meeting, we'll just draw a image of the object. Okay, so it will be what? If this is our A and B, then this will be our A dash and B dash. Okay, so this will be the ray diagram. Means object should be placed, means range of the distance of the object will be what? From between pole and focus, between pole and focus. Or you can say that before 40 centimeter in front of the mirror, right? If you are writing minus 40 centimeter, then you need not to mention in front of the mirror. It will be understood that it's minus 40 centimeter. Fine. Okay. Specify the range of, this is done. Will the image be bigger or smaller than the object? Just you can tell with this, you watching this ray diagram, what you can say that it will be bigger than the object. Okay, bigger than the object. Okay, so it will be bigger. It will be between P and F. Or you can say before minus 40 centimeter. Okay, or 40 centimeter, before 40 centimeter from the in front of the mirror. Draw a ray diagram to show the image formation. This is the ray diagram. Okay, this is the ray diagram. And don't forget, every time whenever I draw ray diagram, I always specify that arrow should be there. Arrow should be there because ray is nothing without arrow. Now, if the second question, if the image formed by the mirror for all position of the object placed in front of it is always erect and diminished. Okay. If the image formed by the mirror for all position of the object placed in front of it is always erect and diminished. Means every time when whatever, no matter what is the position of the object is, we always are getting the erect and diminished image of the object, right? And what is that case? In which case we find the find always the erect image of the object? It's when it's it's when we place the object, and it's when we talk about convex mirror, right? So it is the question of convex mirror. Okay. So all the ray diagrams of concave mirror and convex mirror, you have to mug up this diagram. Because any questions related to this can come in many of the ways. Fine. I'm discussing some of the ways which usually comes in board exams. Fine. So if the image formed by the mirror for all positions, see, for all position, it's only designating that it's talking about convex mirror of the object when of the object placed in front of it are always erect and diminished. Fine. What type of mirror it is? Obviously convex mirror. Draw a ray diagram to justify your answer. Okay. And where and why do we generally use this type of mirror? And you already are knowing that where and why do we where do we use this type of mirror uh, in the mirror of the in the mirror of the vehicles, right? F- uh, right. Rear view mirror in the vehicles means like car and bikes. So we use what? Convex mirror, so that we get erect image and quite diminished image. Okay. So, and what is the second question? This is what type of mirror is it? Draw a ray diagram. Okay, let's draw ray diagram. Convex mirror. We'll draw convex mirror. Its focus and pole will be here, right? It will be positive, and wherever we place the object, no matter where we place the object, parallel rays, it will pass through the focus. So, sorry, it's diverging mirror, no? So it will get diverged. It will be the solid line, and when we extend this line, we'll extend this to here. That it will appear to pass through the focus. And what is the second? The second case is the center of curvature. Center of curvature, the line passing through center of curvature will always comes back following the same path. Okay, this is the image that we have got. This is very diminished image, right? This is what this is the diminished image of the object. What type of mirror is it? And draw ray diagram. This is the ray diagram that we have drawn for this question. Okay. And where and why? And why do we generally use this type of mirror in front, in rear view mirror, as a rear view mirror of the vehicles, so that we'll obtain a smaller image of the object? Because if we obtain the original means the same size as that of the object, then if the truck will be behind us, then we won't be able to see any more or any other vehicles behind us, right? Only truck will occupy uh, all the faces of the mirror. Fine. Okay, तो ये हो गया. Now the third question: when an object is placed at a distance of 60 centimeter from the convex spherical mirror. Okay, so it is given that u is minus 60 centimeter, and it's given that the question is of convex. Okay, convex. So u will be negative convex. Okay, the magnification produced is m is given as 1 by 2. Okay, where should be the image? Where should the object be placed to get a magnification of 1 by 3? It's saying that it wants magnification of 1 by 3. Where should the object be placed? Let us take it as u1. Okay, u1 and m1, because another magnification is also there. So we'll take m1. Okay, so u1 and m1. So we'll just got to know about v1. Okay, so v1 will be what? First we'll find v1. So v1 will be what? As we know from the formula of magnification minus v by u, magnification of mirror minus v by u. Here we are getting m1 as m1 is equal to minus v1 by u1. Okay, so we have to know about v1. So v1 will be minus m1 and u1. So m1 is what? 1 by 2, minus will be minus. So m1 is 1 by 2 and u1 is 60 centimeter. Okay, 60 centimeter, negative 60. So negative will get positive. And this will be what? 30. So it will be 30 centimeter. Okay, it will not be in negative because it's about convex mirror, and also we have verified it that we will be behind the, means object will be the image will be formed behind the mirror. Okay, 30 centimeter. Now we have known about v and u. Do you not think so ki we can know about the focal length of the mirror, and once we will know about the focal length of the mirror, then we can easily find the object distance using this magnification. Okay. Okay, let's find out the focal length of the mirror. So what will be the focal length of the mirror? 1 upon f is equal to 1 upon u plus 1 upon v. Okay, so f will be same for both of the cases, u1 and v1. Here we will use u1 and v1. So u1 is what? Is given as minus 60. So minus 1 by 60. I have taken minus in numerator, and plus 1 by 30. Okay, since it is positive, so we'll keep it positive. So now into 2, taking LCM of 60 and 30, we'll get 60. So minus 1 plus 2 upon 60. It will be 1 by 60, means the F will be 60 centimeter. F has come out to be 60 centimeter. Okay. Now we have to know about where should the object be placed to get a magnification of 1 by 3. Now m2 is given as 1 by 3. Fine, we have to know about u. Okay, let's see what is the relation between what is the relation between u and v is coming out to be. So let's find the relation between u and v. Once we find the relation between u and v, then we can find u and v with the mirror formula, right? With the by using the formula of mirror. Okay, so v m2 will be u2, we have to find, right? So minus v2 by u2, it will be what? Minus v2 by u2. So using this, it will be 1 by 3 minus v2 by u2. So u2 will be how much? Minus 3 v2. Okay, minus 3 v2. Now what about this is the relation that we have obtained between u2 and v2. Okay, using the mirror formula once again, using the mirror formula, using the mirror formula, that is 1 by f is equal to 1 by u2 plus 1 by v2. Now we'll take u2 and v2. F will remain the same because it's about the same convex mirror. So 1 by f we can write in place of f, that is 60, is equal to 1 by u2. So we can write in place of u2 as 3v2, right? In place of u2, 3v2. So minus 3v2. So it will be minus 3v2 plus v2 will be same. Okay, v2 will be v2. 1 by 60 is equal to, we can take out v2 outside. So we'll get minus 1 by 3 plus 1. Okay. So taking the LCM 1 upon 1 into 3 into 3. So we'll get 1 by v2, 3 minus 1, 2 upon 3, 1 by 60. Okay, you must be understanding the calculation. So v2 will be taking v2 here and 60 there. So 60, 2 by 3. So we can cancel this by 20. So it will be 40 centimeter. And we have to know about u2. Okay, v2 we have figured out, and we have to know about u2. We also have we also taken this v2 as minus u2 by 3. We would have directly obtained the u2, right? We would have directly obtained the u2 because we only need u2. But if v2 was also asked, then what we would have done, we would have just use this way. Or we can also take now v2, since v2 is obtained, then we can obtain u as u2 is equal to what? Minus 3v2, right? Minus 3v2, right? Minus 3v2. So we from using this relation, we can find out u2. We can find this u2. Okay, so minus 3 into will be 40 centimeter. So it will be minus 120 centimeter. Okay, this is the u2 that we have obtained. Okay, this is the u2 that is talking about. Where should the object be placed to get a magnification of 1 by 3? Now we'll get the magnification as 1 by 3. Okay, so this is it for today's lecture, and I'll come up with more of the numerical on my next lecture. Till then, tata, bye bye, and don't forget to like and subscribe, like the videos and subscribe to this channel. Bye bye, take care.